June 14th, 2026, 9 a.m. Alaska Daylight Time. The view from space over the Aleutian Arc is deceptively peaceful, a necklace of islands strung across the North Pacific. But beneath this cold blue surface, a catastrophic geological clock is accelerating. Just 7 kilometers, 4 miles, from Unalaska Island, home to Dutch Harbor, the engine of the multi-billion-dollar American fishing industry, a silent, invisible giant is waking up. Hidden 500 meters, 1,600 feet, beneath the Bering Sea, the Amaknak submarine volcano has been building a massive, pressurized magma chamber. A structure that scientists only confirmed recently, and one that new alarming data shows is recharging at a rate that is frankly terrifying. For 4 centuries it has not erupted. 400 years of silence that we mistook for dormancy. But silence in a subduction zone is often a lie. It is the sound of tension building, pressure accumulating, and a system preparing to fail. What happened in January of 2025 changed everything we thought we understood about volcanic risk in the United States. We are not talking about a remote threat. We are talking about a geological gun pointed directly at a vital American economic hub and its thousands of residents. The scale is unprecedented in modern US history. When most people think of volcanoes, they picture Mount St. Helens or the shield cones of Hawaii. But the vast majority of Earth's volcanic engines are hidden beneath the ocean, and we have been blind to them. Amaknak is one of those invisible giants, sitting directly along the eastern Aleutian subduction zone, where the Pacific plate is ruthlessly diving beneath North America. This is the exact geologically active plumbing system that has produced some of the most powerful explosive eruptions in human history. We now know that the Amaknak submarine structure is not only active, but is aggressively refilling its reservoir toward a threshold comparable to the eruption that devastated this region centuries ago. The alarm bells are ringing across monitoring stations from Anchorage to Reston, and the question is no longer if it will erupt, but how long until it reaches critical mass. The revelation of Amaknak's true scale didn't come from a visual sighting, but from a technological breakthrough that allowed us to peer through kilometers of seawater and crustal rock. In late 2022, a study published in the journal Geochemistry, Geophysics, Geosystems utilized the cutting-edge imaging technique called full waveform inversion, or FWI. To understand the significance of this, think of a traditional seismic survey as a blurry X-ray. FWI is a high-resolution 3D MRI. A research team, using sound waves fired from a vessel on the Bering Sea surface, mapped the internal plumbing of the volcano with unprecedented precision. As these sound waves traveled through the Earth, their velocity changed. They sped through solid basalt, but slowed to a crawl when they hit molten material. By processing thousands of these data points, the USGS and university partners constructed a terrifying image, a massive, previously unknown magma chamber. This reservoir extends from 2 to 4 kilometers, roughly 1.2 to 2.5 miles below the seafloor. It is 600 meters wide, holding a staggering 1.4 cubic kilometers of magma. That is approximately 1/3 of a cubic mile of liquid fire, enough to fill over 500,000 Olympic-sized swimming pools. And it is not static. Since the last documented eruption in 1650, this system has been recharging at an average rate of 4 million cubic meters every single year. For nearly 4 centuries, while the world above went about its business, the Amaknak reservoir was silently expanding, pressuring the crust, waiting for a breaking point. Then came January 2025. What began as background noise on the Alaska Volcano Observatory's AVO monitors suddenly transformed into a full-scale geophysical crisis. At 7:22 a.m. on January 27, 2025, a swarm of earthquakes ignited just 6 miles northeast of Dutch Harbor. This wasn't a temporary spike. Over the next 30 days, seismographs recorded more than 30,000 individual earthquakes. The intensity was staggering. The University of Alaska Fairbanks reported 15,000 events in a single 2-week window. The largest tremor, a magnitude 5.2, sent residents of Unalaska scrambling for cover. On February 6, 2025, the governor of Alaska declared a state of emergency for the Aleutian's West Census area. Schools in Unalaska were shuttered. In an unusual move, emergency management officials advised residents to drain large water storage units and industrial tanks, fearing that the continuous ground shaking could induce structural resonance and destabilize foundations. During the height of the seismic storm, roughly 11,000 people, including seasonal workers from the massive fish processing plants, voluntarily evacuated via the port and local airstrip. But the most disturbing data emerged months later, in November 2025, when a study in the journal Nature revealed the coupling effect. For decades, scientists had treated the Amaknak submarine cone and the massive Makushin volcano on Unalaska Island as separate entities. The 2025 data proved they are twins connected at the root. GNSS stations showed a synchronized breathing of the Earth. As the seafloor above Amaknak subsided by 32 centimeters, about 13 inches, the land surface near Makushin rose by more than 10 centimeters. Magma wasn't just sitting there, it was migrating. A magma-filled dike, a sheet of molten rock over 12 miles long, had sliced through the crust at a depth of 6 miles, linking the two systems. We are witnessing a wholesale reorganization of the magmatic plumbing system beneath the Aleutian Arc, noted one senior USGS geophysicist. The two volcanoes are exchanging pressure in real time. It's a unified hazardous system now. This interaction significantly elevates the risk of a simultaneous or triggered eruption. The infrastructure at risk is staggering. Dutch Harbor is the most productive fishing port in the United States by volume. It is the logistical heart of the Bering Sea's king crab and pollock industries. A major eruption or a flank collapse doesn't just threaten lives, it threatens a multi-billion-dollar pillar of the American food supply chain. The clock is no longer ticking in centuries or decades. The 2025 event proved that the subterranean pathways are open, the fuel is moving, and the system is primed for a catastrophic release. To understand the true danger of the Amaknak submarine system, we must look at the scars left by its past. History in geology is not just a record, it is a blueprint for the future. The last major event at Amaknak in 1650 remains a chilling benchmark. According to localized sediment records and early maritime accounts, that eruption didn't just vent gas. It produced high-velocity pyroclastic flows that didn't sink. Because of the intense heat and gas expansion, these flows of incandescent ash and rock actually skimmed across the surface of the Bering Sea, traveling over 4 miles of open water to slam into the cliffs of Unalaska. In 1650, this killed dozens of indigenous Unangan people, a staggering toll for such a sparsely populated era. Today, a repeat of that specific phenomenon would strike the heart of Dutch Harbor, where thousands of seasonal workers and residents live in the direct path of any northward moving surge. But the scale of the threat is even larger when we look at the regional great eruptions. Alaska is home to the most powerful volcanic event of the 20th century, the 1912 eruption of Nova Rupta. That event was 30 times more powerful than the 18th century eruptions of the lower 48, sending ash across the entire continent and cooling the global climate. Scientists at the USGS now fear that the Amaknak-Makushin coupled system has the magmatic volume to rival that scale. The physics of a submarine explosion at 500 meters depth creates a Goldilocks zone of destruction. If the volcano were deeper, the immense weight of the ocean would contain the blast. If it were on land, the atmosphere would absorb some of the initial shock. At 1,600 feet below the surface, however, the pressure is high enough to allow for massive energy accumulation, but shallow enough that when the cap finally fails, the resulting expansion of steam and magma is instantaneous and violent. This is known as a phreatomagmatic event. When 1000 degrees Celsius magma meets the near-freezing waters of the North Pacific, the water doesn't just boil. It flashes into steam, expanding its volume by 1,600 times in a fraction of a second. This acts like a massive underwater shaped charge. Modeling conducted by the NOAA Pacific Marine Environmental Laboratory in Seattle suggests that an explosive collapse of the Amaknak cone would generate a localized tsunami with initial wave heights exceeding 60 feet. Because the source is only 4 miles from the coast, the lead time for the port of Dutch Harbor would be less than 8 minutes. There is no siren fast enough, no evacuation route short enough to move the population of a busy fishing port in that window. The twist that emerged from the 2025 seismic swarm is the discovery of what geologists call the intervolcanic breach. For decades, the Alaska Volcano Observatory treated Makushin, the 6,600-foot ice-clad peak on Unalaska, as the primary threat. But the November 2025 Nature study proved that the two systems are feeding from the same mid-crustal reservoir at a depth of 10 kilometers. This is a twin-engine volcanic system. When Amaknak recharges, it increases the internal pressure within Makushin. When Makushin's glaciers melt due to geothermal heating, it changes the lithostatic pressure on the submarine Amaknak cone. They are breathing together. Scientists have identified a weak layer of hydrothermalized brittle rock along the eastern flank of the submarine cone, likely degraded by centuries of toxic gas emissions. This flank is unstable. A magnitude 6.0 earthquake, common in this subduction zone, could trigger a massive submarine landslide of several cubic kilometers of debris. This wouldn't just be an eruption, it would be a structural failure of the seafloor itself. The resulting displacement would send a wall of water not just toward Alaska, but radiating across the Pacific toward Hawaii and the US West Coast. We are looking at a system where the cyclicity of eruptions is shortening. The 400-year slumber was not a sign of death, but of a clogged plumbing system that is now being cleared by extreme tectonic pressure. The 2025 data confirms the reservoir is at 92% of the estimated pressure required for a structural breach. We are not just watching a volcano, we are watching a pressure cooker with a jammed valve sitting in the middle of America's most vital maritime gateway. Behind the dry technical data of the 2025 crisis are the people who lived through the most terrifying month in the history of the Aleutians. For Dr. Sarah Bennett, a senior seismologist at the Alaska Volcano Observatory in Anchorage, the crisis didn't begin with a bang, but with a low-frequency hum that refused to stop. We call it volcanic tremor, she recalls from her office overlooking the Chugach Mountains. It's the sound of magma physically tearing through solid rock. In late January 2025, our monitors for the Amaknak sector didn't just spike, they screamed. We were seeing 12 centimeters of crustal offset in 48 hours. That's not geological movement, that's a structural failure in progress. For Bennett and her team, the pressure was psychological. They knew that if they called for a full-scale evacuation of Unalaska and the volcano didn't blow, the economic fallout for the US fishing industry would be catastrophic. But if they waited too long, thousands would die. On the ground in Dutch Harbor, the reality was even more visceral. Elias Thorne, a 20-year veteran captain of the crabber-bearing Soul, was at the docks when the 5.2 magnitude quake hit on February 14th. The water didn't just ripple, it boiled, Thorne says. Not from heat, but from the massive release of CO2 and methane escaping the seafloor above the Amaknak cone. You could smell the sulfur 4 miles away. The harbor surge was so violent, it snapped mooring lines like they were sewing thread. We saw million-dollar vessels drifting toward the rocks because the ground beneath the pilings was literally liquefying. This wasn't just a local tremor. It was a systemic shock to the American food supply. Dutch Harbor handles over 700 million pounds of seafood annually. During the state of emergency, the interruption to the pollock and king crab fleets sent frozen seafood prices up by 40% in grocery stores, from Chicago to Miami within 3 weeks. The logistics of the 2025 evacuation were a nightmare of Alaskan proportions. FEMA Region 10 and the Alaska Division of Homeland Security had to coordinate the movement of 11,000 people, residents, cannery workers, and transient crews, off a mountainous island with only one commercial runway and a single deep-water port. The U.S. Coast Guard diverted 3 national security cutters to assist, turning the Bering Sea into a staging ground for a mass exodus. The cost of the 30-day shutdown exceeded $1.2 billion in lost revenue and emergency expenditures. But the physical damage to infrastructure was more insidious. The coupled nature of the Amaknak and Makushin volcanoes meant that geothermal activity spiked across the island. The local power grid, which relies on a mix of diesel and geothermal energy, suffered multiple transformer fires as ground temperatures near the Makushin geothermal test sites rose by 15 degrees Celsius in a single week. Submarine infrastructure faced an even greater threat. The GCI fiber optic cables that provide high-speed internet and vital telecommunications to the Aleutians ran dangerously close to the Amaknak volcanic field. During the January swarm, 2 major undersea landslides, triggered by the 5.2 quake, severed the primary link. For 5 days, the most strategically important region of the North Pacific was effectively dark, forced to rely on aging satellite backups with limited bandwidth. This wasn't just a communication failure, it was a national security vulnerability. The US military, which maintained sensitive monitoring stations in the region, found itself operating in a zone of total geophysical chaos. The ecological toll is still being calculated in 2026. The massive venting of toxic gases, sulfur dioxide and hydrogen sulfide, created a localized dead zone in the water surrounding the Amaknak cone. Divers from the University of Washington, using ROVs in late 2025, found thousands of acres of seafloor covered in a fine acidic ash that has decimated the local crustacean nurseries. If the volcano reaches a full-scale explosive phase, the tephra fall alone would ground every flight across the Great Circle route, the highway of the sky that carries nearly half of all air cargo between Asia and the lower 48. We are talking about a $15 billion impact on the US economy in the first 90 days of a major eruption. Every American who buys a laptop, a smartphone, or a bag of frozen fish is connected to the stability of a seafloor 4 miles from Unalaska. The 2025 crisis was a warning shot, a stress test that revealed our modern high-tech society is fundamentally fragile when confronted with the raw, archaic power of the Aleutian subduction zone. As we move through the spring of 2026, the deceptive silence returning to the Amaknak sector is not a relief to the scientific community, it is an omen. The internal pressure within the coupled Amaknak-Makushin system has not dissipated, it has merely stabilized at a critical threshold. The Bering Shield Expedition, a joint venture between the USGS, NOAA, and the University of Washington, departed from Seward in April 2026 to deploy the most sophisticated submarine monitoring array ever seen in the North Pacific. Using the research vessel Oceanus, scientists are currently installing fiber optic sensing cables directly across the Amaknak crater floor. This technology, known as Distributed Acoustic Sensing (DAS), turns every inch of the cable into a highly sensitive seismometer. The initial data streaming back to the Alaska Volcano Observatory in Anchorage is sobering. The seafloor isn't just vibrating, it is deforming. Since the Great Swarm of 2025, the central cone of the Amaknak submarine volcano has risen an additional 8 centimeters. The magma chamber is not just recharging, it is aggressively seeking a path to the surface. The risk profile for the next 24 to 36 months has shifted from possible to statistically probable. We are looking at 3 distinct high-impact scenarios that could reshape the American landscape. The first is a catastrophic phreatomagmatic eruption. If the 2.0 cubic kilometer magma threshold is breached, a volume the USGS estimates we will hit by mid-2027 at current recharge rates, the resulting explosion would be visible from space. The immediate casualty would be the port of Dutch Harbor. Beyond the loss of life, the destruction of the processing plants and the Unalaska airport would trigger a blue economy collapse. The Bering Sea pollock fishery, which accounts for nearly a third of all seafood consumed in the United States, would be shuttered for years. This isn't just about the price of fish. It's about the total failure of a regional economy that provides tens of thousands of American jobs and billions in tax revenue. The second risk is the ash corridor. Anchorage International Airport is the fourth busiest cargo hub in the world. On any given day, hundreds of wide-body freighters from FedEx, UPS, and Atlas Air transition through the airspace directly downwind of the Amaknak Makushin complex. A VI5 eruption would send a plume of abrasive, glass-rich volcanic ash 60,000 feet into the stratosphere. In 1989, a single encounter with ash from Alaska's Redoubt volcano nearly caused a Boeing 747 to crash after all four engines flamed out. A sustained eruption at Amaknak would effectively sever the primary air bridge between the United States and the manufacturing hubs of Asia. Logistics experts at the Department of Transportation have modeled a 12% permanent increase in global shipping costs if the North Pacific Great Circle routes are forced to divert south, bypassing Alaska entirely. The third and perhaps most terrifying scenario is the flank collapse tsunami. The 2025 data confirmed the existence of a massive, unstable wedge of rock on the eastern side of the Amaknak cone. If this 3 cubic kilometer mass slides, the resulting wave would reach the shores of Hawaii in less than 5 hours and the California coast in 6. Unlike the Pacific Tsunami Warning System's deep ocean buoys, which monitor distant quakes, a volcanic landslide provides almost zero seismic warning. The wave is the first signal. For the coastal communities of the US West Coast, from Crescent City to San Diego, the margin for error is non-existent. Our early warning infrastructure is world-class, but it is calibrated for tectonic earthquakes, not the sudden, localized displacement of the seafloor by a collapsing volcano. The inevitability of this event is written into the chemistry of the rocks. The African plate doesn't stop diving under Europe, and the Pacific plate doesn't stop diving under North America just because we have built cities and ports in the way. The geological clock doesn't care about fiscal years or election cycles. The Amaknak volcano is a physical system governed by thermodynamics and structural mechanics. It will break when the pressure exceeds the strength of the rock. That is a mathematical certainty. What we are doing now, the monitoring, the data collection, the simulations, is an attempt to turn a surprise catastrophe into a managed disaster. We are learning to listen to the Earth's breathing, to the low-frequency whispers of magma moving through the crust, and to the subtle tilt of the seafloor. In the coming months, the USGS will continue to release updated hazard maps for the Aleutian Arc. The Project 2027 forecast models suggest that the probability of a major eruptive event has risen to 1 in 15 within the next 3 years. This is one of the most significant ongoing geological stories of our generation, unfolding in real time in a remote corner of American soil. It is a story of hidden power, of a silent giant that has been recharging for 4 centuries and has finally decided to wake up. We will continue to follow every sensor reading, every satellite image, and every report from the Bering Sea, because in the face of tectonic fury, awareness is our only true defense. The data is clear, the trend is accelerating, and the next chapter of the Amaknak volcano is already being written beneath 500 meters of cold, dark water. Subscribe and stay tuned as we track the pulse of a changing planet. The clock is ticking, and the Earth is moving.